what you need to begin calculating local anesthetic dosages and vasoconstrictor dosages. So when you calculate how much anesthetic you have given to a patient, you will always be calculating the milligrams of the local anesthetic drug and the vasoconstrictor drug you have administered, in addition to the volume of the solution, which is how much liquid is inside the cartridge. To calculate these drug dosages, there are three things you need to know. The concentration of the local anesthetic drug, for example, lidocaine is 2%, mepivacaine is 3%, articaine and prilocaine are 4%. The dilution of the vasoconstrictor, if present. Not all cartridges contain a vasoconstrictor such as epinephrine, and those cartridges are considered plain. But if the vasoconstrictor is present, you usually see it in a dilution ratio of 1 to 100,000, and also the volume of the solution administered. So maximum recommended dosage, from here on out, I will be calling that the MRD. The MRD of a drug is the maximum amount that a patient can be given in one appointment. Giving more than this amount may result in drug toxicity and other adverse effects. MRDs are established by the drug manufacturers and are always included in package insert for the drug. So there are two types of MRD. The first type that we'll look at is the absolute maximum. No patient, regardless of size, weight, or health status, should be given more than this amount of drug. And you will calculate the number of cartridges that can be given safely administered per appointment by using the drug MRD in milligrams and dividing that by the drug milligrams per cartridge. And we'll do some of those in just a couple of minutes. So there's another maximum recommended dosage, and that's calculated by weight. This is an individual's MRD for a patient, calculated by the patient's weight. Calculated MRDs are for smaller patients who cannot tolerate the same amount of drug as a standard patient. And the standard patient, we usually say, is between about 150 to 160 pounds. So if the patient weighs much less than that, you will use the weight-based MRD. And the way you get the weight-based MRD is to calculate the individual MRD by weight and calculate allowable cartridges. So you'll use the MRD, which is milligrams per pound, and you will multiply that by the patient's weight in pounds, and you will get the specific MRD for that patient. And we'll do some of those calculations as well. So MRDs for injectable dental anesthetics, here are some. 2 and 3% mepivacaine has a weight-based MRD of 3 milligrams per pound and an absolute MRD of 400. 2% lidocaine is 3.2 milligrams per pound as a weight-based MRD and an absolute MRD of 500 milligrams. And then you can read the others and refer back to them for the math calculations you'll be doing for your activity. Prilocaine, articaine, and bupivacaine. So local anesthetic drugs are expressed as a percentage. So you can see 2% lidocaine, 3% mepivacaine, 4% prilocaine, 4% articaine, and 0.5% bupivacaine. So some cartridges, such as 3% mepivacaine, contain only mepivacaine. They don't have an additional vasoconstrictor. But almost all lidocaine, 2% lidocaines, contain a vasoconstrictor within the cartridge. And in that case, you'll have to do math calculations for both drugs that are inside the cartridge. So what does 2% mean? Because 2% is probably the most common one you'll see because it's lidocaine. So a 2% solution, and for here we'll say it's lidocaine. What 2% means is 2 grams of lidocaine per 100 milliliters of water. And we're never talking about grams. We want to get it really way down from grams to milligrams. So we convert it into milligrams. So when you convert 2 grams into 100 milliliters, you get 2,000 milligrams over 100 milliliters. And I always remember from my math many years ago, if you had 2 zeros here and 2 zeros here, you cross them out. I don't know if people still do that anymore. And you end up with 20 milligrams per 1 milliliter of water. So 20 milligrams of lidocaine per 1 milliliter of water. And then the 3% is 3 milligrams per 1 milliliter of water, and 4% solution is 40 milligrams per 1 milliliter of water. Now, dental cartridges are not 1 milliliter. So we need to do an additional step to find out how much lidocaine, 2% solution, 2% lidocaine is in one cartridge. So for anyone that's interested, when you're doing the math, you don't have to start it here at 2 grams. This is just to show you what 2% means. The 2% means 2 grams over 100 milliliters. If you can start 2% means 20 milligrams over 1 milliliter, that's perfect. That's where you need to start the equation. If you want to write it all out, you can write it all out if that helps you, or you can start it here, 20 milligrams of lidocaine per 1 milliliter. And the 3% solution would be mepivacaine. So in 1 milliliter of water, a 3% mepivacaine solution would have 30 milligrams. And prilocaine at 4% and articaine at 4% would have 40 milligrams per 1 milliliter. So the next step, what we want to do next, so dental cartridges are either 1.8 milliliters or 1.7 milliliters. You will be given the amount that is in the cartridge in whatever equations I give you. All right, so one cartridge equals 1.8 milliliters. Sometimes the cartridge will be 1.7 milliliters. So we saw on the previous slide that the 2%, I'm going to put here, lidocaine solution equals 20 milligrams per 1 milliliter. So that 20 milligrams over 1 milliliter times or multiply by how much is in each cartridge, 1.8. We cross out the milliliter here, and you get 36 milligrams per cartridge. Now, if the cartridge is only 1.7 milliliters, you'll do the same thing, 20 milligrams over 1 milliliter, multiply by 1.7 milliliters, which will give you the 35 milligrams of lidocaine per cartridge. Let's say lido, because that's the drug we're talking about here. Now, this would change if we were talking about articaine or prilocaine, because that's a 4% solution. So I'm just going to say if it was a 4% solution here, that changes that to 4%. Then you would have 40 milligrams. The cartridge remains the same. And then you would get, let me do fast math here, not very fast, 72 milligrams. And then it would be here, articaine per cartridge. But we're just going to go back to the Lido. So that's how it would change per cartridge if you change the drug. Go back here, 20, and then we go back to our 36. So that's for Lido. And then here I've just broken it down, 2% solution, the 3% solution, the 4% solution, and how you get to the milligrams per cartridge. And it depends, of course, on the drug. The 2% is lidocaine, 3% is usually mepivacaine. There is a 2% mepivacaine. We don't see it very often, but it does exist. And then 4% is prilocaine and articaine. So those are the most commonly used drugs. Oh, there's a lot of math on here. So dose calculations with an absolute MRD. So 2% lidocaine, 2% is the 20 milligrams of lidocaine per 1 milliliter of water, and the one cartridge we have here is 1.8 milliliters. So that brings us here to the 36 milligrams per cartridge. The absolute MRD, maximum recommended dosage of lidocaine, is 500 milligrams. So the 500 milligrams is in the numerator, and the 36 milligrams per cartridge is in the denominator. So you divide the 500 by the 36 milligrams per cartridge, the milligrams cancel out, and you end up with 13.8 cartridges based solely on the lidocaine. Now remember, we need to talk about vasoconstrictors. So for right now, for this patient based solely on lidocaine, 13.8 cartridges is the maximum safe or maximum recommended dosage for this healthy patient based on the lidocaine. So let's look at weight-based. So we have a patient that weighs 100 pounds. So we calculate, same thing, 2% lidocaine. It equals 20 milligrams of lidocaine per 1 milliliter of water, the 1.8 milliliter cartridge. So we end up with 36 milligrams of lidocaine in one cartridge. Now the MRD of lidocaine based on weight is 3.2 milligrams per pound. So we have 3.2 milligrams per 1 pound multiplied by the 100 pounds, which is the patient's weight, and that gives us 320 milligrams. So for this 100-pound patient, they can only receive 320 milligrams. So how do we convert that to cartridges? We put the 320 milligrams in the numerator, the 36 milligrams per cartridge in the denominator, the milligrams cancel out, and you end up with 8.8 cartridges is the maximum safe or recommended dose of lidocaine based only on the lidocaine for this 100-pound patient. And it's very important that you never exceed the absolute MRD. For example, 2% lidocaine is 36 milligrams of lidocaine per cartridge. The absolute MRD is 500 milligrams. So we already figured this out a couple of slides ago. The absolute MRD with 36 milligrams per cartridge, you can have 13.8 cartridges based solely on the lidocaine. Now the weight MRD is 3.2 milligrams per pound. What if the patient weighs 200 pounds? So if we figure out here, the 200 pounds times 3 or multiply by 3.2 milligrams, you end up with 640 milligrams. 200 pounds. Yeah. Okay, so the pounds cancel out, 640 milligrams, but we already know the absolute MRD is 500. So it doesn't matter if the patient weighs 200 pounds. You can't go over 500. So the weight-based MRD is not usually used for patients that are heavy. It's used for lighter framed, smaller individuals. So it's very unlikely that you'll only use one cartridge. So what happens if you administer multiple cartridges? So you deliver 2 cartridges of 3% mepivacaine. How many milligrams of mepivacaine did you deliver? So 3% is 30 milligrams of mepivacaine over 1 milliliter of water. The cartridge is 1.8 milliliters. So 30 milligrams over 1 milliliter multiplied by 1.8 milliliters per cartridge gives us 54 milligrams in one cartridge. That's in one cartridge. We have to come back up here. You deliver 2 cartridges. So then 54 milligrams times 2 cartridges equals 108 milligrams of mepivacaine that you've delivered. And then sometimes you don't deliver a full cartridge. So this is the same equation as before that we get to, that we have 54 milligrams in one cartridge, but we've only administered a half a cartridge. So 54 milligrams divided by 2, because you use half the cartridge, 27 milligrams of mepivacaine was delivered to this patient. Now we need to take a look at vasoconstrictors. So that's what we've looked at just this past few slides is local anesthetic drugs. Now we'll be looking at epinephrine. The MRDs of vasoconstrictors are based on the health of the patient, whether they have cardiac issues, high blood pressure, things like that, and the dilution of the vasoconstrictor expressed as a ratio. For example, 1 to 100,000 epinephrine means 1 gram of epinephrine per 100,000 milliliters of water. So the 1 is 1 gram of epinephrine. So this part right here is the epinephrine, and this is the water. You need to memorize these. So for epinephrine, for a healthy adult, the maximum amount of epinephrine that a patient can receive in one appointment is 0.2 milligrams. For a cardiovascular involved adult, including any kind of cardiac issue, high blood pressure, anything like that, they can receive 1/5 the amount of a healthy adult. So a cardiovascular adult can only receive 0.04 milligrams of epinephrine per appointment. So lots of math here. 1 gram of epinephrine, so 1 to 100,000 means 1 gram of epinephrine per 100,000 milliliters of water. So we want to get this down to the smallest possible piece. So we convert to milligrams. So 1 gram equals 1,000 milligrams of epinephrine in 100,000 milliliters of water. 3 zeros here, 3 zeros here, which equals 1 milligram of epinephrine in 100 milliliters of water. And remember, our cartridges are only 1.8 milliliters. So we divide again the 100 into the 1, and we get 0.01 milligrams of epinephrine per 1 milliliter of water. But our cartridges are not 1 milliliter, they're 1.8, sometimes 1.7. So then what you need to do is take that 0.01 milligrams of epinephrine over 1 milliliter of water, multiply it by 1.8 milliliters per cartridge to get to 0.018 milligrams of epinephrine per cartridge. And these are some common dental ratios of vasoconstrictor. The most common one and the one that we'll be using almost exclusively in pharm is the 1 gram of epinephrine to 100,000 milliliters of water right here. So because the 1 is the epinephrine and the 20,000, 50,000, 100,000, 200,000 is the water, you can see that the 1 to 20,000 is the most concentrated of epinephrine. And the way I like to think about it is the 1 of epinephrine, it's like when you put sugar into a coffee. And so this would be a small coffee, and this would be the medium, and this would be the large because this is a liquid, and this would be like extra super grande. If you only put the 1 teaspoon of sugar, which is here's the epinephrine, which one would be the sweetest, in the small cup or in the extra grande? In the small cup. So that's how it's like the most concentrated. I think about it, it would make it the sweetest if we were talking about coffee sizes and a teaspoon of sugar. All right, so now we have to figure out how many cartridges based just on the vasoconstrictor patient can have. So the healthy MRD is 0.2 milligrams of epinephrine. Cardiovascular is 0.04 milligrams. So this is epinephrine in the dilution of 1 to 100,000. So we have calculated that that means 0.018 milligrams of epinephrine are in each cartridge. So you put the MRD in the numerator. So here is the healthy one, 0.2 milligrams of epinephrine. And in the denominator goes as 0.018 milligrams of epinephrine per cartridge. And a healthy patient can have 11 cartridges based solely on the vasoconstrictor. So the next equation is the cardiovascular MRD, 0.04 milligrams of epinephrine The cardiovascular MRD goes in the numerator, and the 0.018 milligrams of epinephrine per cartridge is in the denominator. And now look at this, they can only receive 2 cartridges for the cardiac involved patient based solely on the epinephrine in the dilution of 1 to 100,000. So the last thing we're going to talk about is something called the limiting dose. So lidocaine, we determined based on lidocaine, someone could have 13.8 cartridges based on the healthy patient based on the lidocaine. If the person is 100 pounds, they could have 8.8 cartridges. Based on epinephrine, 11 cartridges. Based for the healthy patient, and for the cardiac patient, they can have 2. So we have to figure out which drug is the limiting drug, because most of the time lidocaine and epinephrine are combined in the same cartridge. So if we have a healthy 165-pound patient, and we look at this equation, healthy 165-pound patient, they can have 13 cartridges based on the lidocaine, 11 based on the epinephrine. So the maximum amount of cartridges they can have is 11. The limiting drug is the epinephrine. We have to make sure, because we have 2 drugs in there, one of them will limit. You'll reach the limit of one drug first, and that drug becomes the limiter. So for here, it's epinephrine is the limiter. Now, if the patient was 100 pounds and was healthy, they could receive 8.8 cartridges of lidocaine based on lidocaine and 11 cartridges based on epinephrine. So the limiting drug that we'll reach, the limiter that we'll reach first here is the 8.8. So then the lidocaine becomes the limiting drug. If it's a cardiovascular patient, the epinephrine will always be the limiting drug at 2 cartridges. So cardiovascular patient, epinephrine is almost always the limiting drug. Otherwise, you'll just have to look and say, okay, I can have 11 cartridges based on epinephrine and 8.8 based on the weight-based MRD for lidocaine. They can have 8.8. All right, so that's the math. And there is going to be some math take-home quiz that you'll pass in. And I will take a look at it and see who might need some extra math tutoring.